Welcome back. We're back on the FL-2100 and well, trying to sort out the input SWR and turn it on, and it went pop. The whole left hand string of the diodes are actually shortened. So I think one went pop and the others just followed. We're gonna change all 10 of them because they are old and they might not be very good anymore. We also check the resistors just to make sure they're all good, because they're supposed to balance the voltage over the diodes. We need to work on this end here. The problem is that the thing is designed for a tube exciter, but modern transceivers, semiconductor transceivers, they don't like bad input matching, and it's not very good. It's about SWR is about 2 uncertain bands, so we need to work on that as well. I think we need to measure the capacitors on, I think it was 40, because 40 is extremely bad. I don't know why. It's gotta be the input circuit, because the output tunes well. We had it working fairly well. It was doing about 300 watts on 20 and 80. On 40 it was probably doing about 250 with the dull tubes. The reason for 40 meters is just the input SWR is so poor. The transceiver drops the power down to about 25 watts. So we need to work on that as well. Well, okay, let's fix those diodes and give it another try. I don't know if that's visible because the camera is on the magnifying glass, but you might be see some metal spray here, and where's the other one, and here. Hopefully that's fairly in focus. The diode split and the stuff inside actually just came out, and that took them into semiconductors heaven. Alright, let's change them. So it would have been too easy if it's just one thing. We've just checked those resistors here, and they are supposed to be 470k, but none of them is actually 470. And if we look closer, we can see that's about 600. That's 580. That's 600. I think this one was the lowest one, 560. If you look closer, I think it's not visible on camera. You can see that somehow the body has separated from the wire, where the wire goes in. So I think they just seen enough heat cycles. So maybe that's one of the reasons why it died, because obviously the voltage distribution over the diodes was not equal. That certainly kills the thing. So we're gonna pinch those all out. I got a bunch of new ones, hopefully enough. They look like half watt or so. Size wise they should fit. I'll make some more. We'll find out. And we just redo the whole board with new components, but that leads me to the assumption that other resistors might be faulty as well. Probably worth checking all the values, because it's aging by heat. That's what it is. Alright, it would be too easy if everything works straight away. It's quite interesting. We knocked them out, and there is no physical damage visible outside, except that where the wire goes into it, it looks a bit odd. I didn't desolder it, I just pinched them all off, and then you just heat the thing up and knock it on the table, and the whole thing comes out. It's a lot. It's not so much stress for the board, and makes life a little bit easier. Alright, let's carry on with redoing that. So we've done the refurb here. We used 1 in 54/8, which is a 1 kilovolt 3 amp diode. I decided to go for the bigger ones because the original diodes are, I think, 1.5 amps. So this is 1 kilovolt, 3 amps per diode. Again, all the resistors were strange. They all increased in value considerably. Unfortunately, I had only 9 of this type here, and only a few of those, but I matched it as best as I could. Both rows are matched as well, so we should have a perfect distribution here. What we're also going to do, we fit a fuse and a sort of blow away resistor in series with the output, or with the input to the rectifier board actually. And also I'm thinking making a little circuitry which provides me some sort of soft start, so the inrush current isn't so high. Just use a relay and a rectifier, or a couple of diodes, and just rectify it from the filament voltage. Okay, we fitted a fuse. It's not a high voltage fuse, but it's more for protection of the whole thing, so it's okay. We fitted a 10 ohm resistor. In normal operation it doesn't harm actually, because it's only stealing about 10 ohms by half an amp is 5 volts. That's 2.5 watts dissipation here on full current, half an amp, and so it should be okay. The voltage drop doesn't harm, but what it does, if the fuse isn't quick enough, just the resistor blows up. I deliberately fitted it from the transformer output into the rectifier, because the rectifier is suitable for 3 amps, the fuse is 2 amps, fast blow. I also fitted a 10 nanofarad 3 kilovolt capacitor over the diodes, just to make sure there's no HF going into the diodes, which may cause high voltage or something like that. Next one will be this electrolytic. I think it's pretty old, so we're gonna change that as well, just while we're at it. And then we need to work on the input circuit. Well, apparently that capacitor looks alright. It's got an ESR of 0.5 ohms, and it reports 1300 microfarad. So we leave that, because the new one is not actually, I had a new one, but that's actually not better, so we just leave it in. It's not critical, it's only the low voltage for the relay. So we've done a bit of tinkering and adjusting and things like that. Still need to fit the soft start, but it seems to work okay. 2.4 kilovolts high voltage, and if we look at the meter, so we're running against the dummy load. That's about 50 watts of drive, and that's just about 300 watts out. I can drive it a bit harder, but I don't really want to do it. That's 40 meters now. I'll check the other bands, but it's alright to me so far. If you look at the current drive here, it's about 250 milliamps of plate current. I'm almost certain I can do a little bit more with the tuning, especially on the input side, but apparently the ICOM deals a lot better with the input circuitry. It's much more tolerant against poor SWR than the Kenwood. I noticed that earlier. It needs to be tuned properly, otherwise it doesn't do the 100 watts machine. I need to check the SWR now. I did a bit of tuning on the circuitry here, but that's alright. So let's try it on the air eventually and see what comes out of it. Yeah, we'll check 80 and 20 and 15 maybe. I'm not really interested in 10 meters because the PA is not very good on 10 either. So looks quite promising. Let's try the other bands and see what's going on here. Well, today I've got a parcel with some Golden Dragon 572Bs in it. Packaging looks interesting. We got it hooked up, screen to anode, and obviously the heater, and just heating it. And then we're driving 250 milliamps, which is about here, and that gives us just shy of 42 volts. So that's a lot better than what we had before. We'll leave that sitting for let's say another 15 minutes at least. We already have it about 15 minutes, and then we check the next one. They came as a matched pair, but yeah, I only trust what I see. So we'll see if they're any good. And behaving okay. It's about what you expect from a new tube, because the old ones, I could put 70 volts on and they were only doing just above 200 milliamps, so we know they're dull. And interestingly, if you compare them to a Citroen, you can see they're taller, the Citroens. It makes about 5 millimeters, which is good. In the FL-2100 it really helps if the tubes are not as long, because you got a bit more headroom there. But apart from that, the size of the anode looks pretty much the same. So we'll see. The only thing which looks a bit odd, that top plastic part, that white plastic part, it's a bit off angle, let's say this way. But we'll see how they behave. Okay, let's cook this one and we'll come back for the next one. We also got a parcel from Poland. These are 220 microfarads, 500 volts capacitors. So, guess where they go? They go to the FL-2100 at some point. We just measured one of them, and it turns out as 200 microfarads, but the ESR is pretty low. It's 0.31 ohms, so I think we can live with that. We measure a few just to see if they equal in capacity. I don't trust this little tester that much, but it gives you at least an indication if they're equal or not. So that's what we get with the proper capacitance meter, and apparently the 200 microfarads are correct, so it's not 220, it's 200, pretty much all of them. Alright, whatever. Well, it turned out they're all sort of similar. They're all in the 200 microfarad range, so it's not 220. That's within the plus minus whatever 20%, or they're made by Vishay. That's what it says here, if it's true. But I could not work out the manufacturing date. Probably 2006, but I'm not entirely sure. I think we're gonna reform them a little bit, and then we do another test and see how good they are. Because they may be sitting there for quite a while. Interestingly, they've not been supplied with a wire, because what you normally do on high voltage capacitors, if you store them, you put a wire in between, just here, something, just to make sure they're not charged with lethal voltages, because this thing is good for 500 volts, so it can actually hurt you quite badly. So before you take any high voltage capacitor out of the packaging, or when you take it out, short it out, normally with a resistor, but just punch it on something metal, and make sure you're not gonna get hurt from that thing, because it's serious. Back in school, when I remember that, we had good fun just throwing charged capacitors people into their pockets, and it was always good fun. Alright, we baked the first one in for half an hour, and it's interesting, they're actually gaining emission here if we look at this, it's 250 milliamps and it's down to about 39 volts now. So we gained a little bit of emission by cooking that tube for half an hour. So let's do the next one and see how we get on. Well, the second one turned out to be weaker than the first one. I ordered a matched triple just to have a spare. And if you look at the box, it says grade 31 and on the other one it says grade 33. I don't know what that means. Fact is that this one, after 15 minutes, pulls only, well, it pulls the same current, but 250 milliamps, and we are up at 45 volts. So this is a weaker tube. Let's just leave it cooking for another while. I know ideally you're gonna heat those with AC, but I don't have an AC source on hand at the moment. At least nothing which can drive that current. So we leave that cooking for a while, and then we test the third one and see how that is. But this, I'm not super happy, let's say this way. Well, it's now half an hour gone and I put a spring there just to rule out it's the connection. And we're still on 45 volts, which is a bit of a disappointment. Let's crank that up to 250 milliamps, and yeah, just over 44 volts, 45 volts, which is a bit of a disappointment because they're significantly different. Alright, so we're gonna check the next one and see how that one looks like. Well, we cooked number 3 now for about half an hour, and it appears it is as good as number 1. If we crank it up to 250 milliamps, we're getting about just under 40 volts like the other one. So this is the same. Only the second one was worse. So let's see what we do there. Maybe we cook it for another half an hour, maybe it's getting better. It's strange. Anyway, let's get the wires off and put it into the PA. So that's still with the old tubes. Everything looks okay, nothing burned or so, because we did quite a few hours of QSOs with the machine here. Looks all good. This was the better tube, this was the worse tube. When you work on a high voltage system, just ground it. It's for your safety. I measured the voltage first and just made sure there is nothing lethal on it. Never short it out directly, always check the voltage first, and if it's only a little, you can do it, otherwise use a resistor. You may burn something. Alright, let's get the tubes out and the new ones in. Well, a brand spanking new set of 572Bs. What I've noticed is that the pins, they might be slightly thicker because it's quite hard to push them back into the socket. But apart from that, they look the same as those here. So maybe those are golden dragons as well, I don't know. There's no marking on it. It doesn't say it. But they got the same length. They're also a bit shorter than the Citrons. Alright, let's get the ground lead off and put the cover back on, fire it up and see how it looks like. So we just tuned up the PA on 40 meters with the new tubes, and we're driving a fair amount of power. It's 400 milliamps. We're actually going into the dummy load. It's about 450 watts without driving it hard. So that's fine. Happy with that. Not too bad for the old girl. And it just drops about, it drops to about 2 kilovolts. I think if we put the new caps in, it's a lot better. Still need to do that. I'm happy with that for now. I tried it last night on 80 and it was great. Anyone said it sounds great, and so I'm happy with that. It looks good on the spectrum analyzer as well. So we're good to go. Thanks for watching. Thanks for subscribing. Until next time, when we most likely gonna do the capacitors.